And we should be live. Hello, everyone. How's it going? Hopefully my microphone is not too quiet. I hope you're all having a wonderful Thursday. And I thought, well, I've got a few things planned. I thought we'd start off by fixing this phone, which is, it seems a little bit broken at the minute. So we'll be making a new postmarketOS install and kind of wiping it. And I thought we'd have a go with kind of the stock postmarketOS experience. So we'll go stock in RMFS. We will kind of wipe the phone. This means you can't dual boot with Android, but we can try out the on-device installer and we can try out full disk encryption too. So the first thing that we need to do is, of course, run pm-bootstrap in it. Yep, we want firmware. I'll pick my username. I think we'll go with Gnome because, well, it's very similar to Flush, and for it renders desktop applications a lot better, obviously. We can leave all of these options as their defaults. Yeah, so I've had some people bug me a lot to try running some games, particularly with Box86, which is a x86 compatibility layer for AX64. And right now, pretty much the only device people are testing on is the Raspberry Pi 4, which is great, but you know, a device with a Snapdragon 845 has a little bit more GPU and CPU horsepower, at least in theory. So now we've initialized pm-bootstrap. We'll do pm-bootstrap install with --dash on dev, which will basically set up an on-device installer. Oops. So with this, we will be able to, well, most of the installation will happen on device after we boot. We can pull up pm-bootstrap log in this terminal so we can see what's going on. So right now it's just setting up the rootfs. And while this is happening, let's see if we can, so this phone is running postmarketOS right now, but for some reason the display is stuck off. So we will need to fix that. I really have no idea why. Actually, it could be an issue with this kernel that's running on it, but anyway, I think for now, we will reboot into fast boot mode. And I'll boot into TWRP and make sure that I don't have any important data, because for the on-device installer, we'll actually be flashing the root file system to the user data partition, because currently postmarketOS only supports using partitions as that it doesn't support using an image as the root file system. Although that is something that would be good to improve in the future. Whilst this is going, I should announce that we are live. Oh. The postmarketOS on-device installer. There we go. Oh. Now then. What's happening? What is happening with this phone? It seems to be a bit stuck. There we go. Alright, so we can check the current slot with fastboot get var current slot. I have a helpful alias and another alias to switch slots. So the B slot has some Android 9 install on it, I think. So we can boot maybe it's Android 10. I think it is. So we'll boot TWRP 3.5. Hopefully you can see that down in the bottom right. Of course, please do let me know if you have anything you'd like to see me work on. I have a bit of a list of ideas, but of course, I'm always open to new ones. So here we go. You can see I don't have much. This is just a development device at this point. So yeah, in fact, part of the reason that I've never tried out the on-device installer before now is because this was actually the phone that I was using for my daily life, I suppose. And I wanted to be able to run postmarketOS and, you know, develop for it and work on mainline without needing to, while still being able to use it for Android and actually important things that I need a phone for every day, because I didn't own any other phones at the time. So that's why I originally wrote my initramfs and install scripts and such. How are we doing? It looks like we are done, apparently. Awesome. So we don't seem to have any files I want to back up, so we'll head back to the bootloader. Let's see. There we go. You should be able to see this page now. So I have written some instructions on using the normal postmarketOS install. I forgot to do a split install here. Last time I did not do a split install, the initramfs was unable to find the extra partition because subpartitions didn't seem to work properly. Let's see if it'll work this time. So PM Bootstrap, Flasher, Flash root fs. I'm not sure what partition it's going to flash to. So I suppose we'll find out. Maybe it will, hopefully it will ask me. Otherwise we'll have to, oh. Well, that's not what we want. Okay, let's try flashing this again, shall we? So we can actually run PM Bootstrap export, and that will basically expose all of the images that it's created as symlinks in /temp, so we can just flash them ourselves. PM Bootstrap has a lot of utilities that make working with Android devices and well, kind of any embedded device really quite straightforward. It is rebuilding the inner MFS again, though. There we go. Okay, so now we should be able to fastboot flash user data, temp postmarketOS export, and then I imagine it'll be this image. Oh, I think because we interrupted the previous flash, it will be a bit unhappy. So we'll reboot back into fastboot mode, and there we go. That's better. And this should take about a minute. How's it going, Geotech Land? Yeah, I'm a little unsure on exactly how to pull all this together. Oh, there we go. Still learning the OBS keybinds, but it should be good. I've had to move the microphone from, I did have it up above my monitor, but it was a bit too far away, and it meant that my voice didn't sound that great. There was a lot of background noise because, well, microphones with built-in DACs pick up on all of the USB noise on your hosts, so that's not too great. I will also probably need to improve this camera. Right now it is actually my OnePlus 6T running Droid Cam and getting nice and warm for us. But it's only a 640 by 480 video feed, which is, it's not very much. Unfortunately, a large part of this work is kind of just waiting. It's been longer than 12 seconds, I think, but who knows? Hopefully it hasn't died. Fastboot is not the best tools to use, and it doesn't help that every vendor, of course, has their own implementation. For example, on the OnePlus 6 wiki page, there's a note because I previously was running a fairly cheap motherboard, Ryzen motherboard, and the USB controller, I think, just didn't play nice with fast boot. So, wow, that took a really long time for some reason. Yeah, so what happened is if the device is sat in fast boot mode and you try and like run fast boot commands, it would just fail and it would return weird errors. So when I try like flashing boot, it would say stuff like the device does not support slots, which is like, what? Really weird stuff. Or just failed, no such device, stuff like that, even though when you run fast boot devices, it shows up. And the workaround that I found is to reboot the device into fast boot mode. So like pick a restart bootloader and hit the power button to go, and then run the fast boot command whilst it reboots. So fast boot would say waiting for device, and then as soon as the device appeared, the command would get run and it would flash, and that would work 100% of the time. So something weird is definitely going on there, but who knows? And I have a new motherboard now, so I don't have to deal with that quirkiness anymore. All right, we have flashed the rootfs, so now we can flash the boot image, which will be boot.img. And now just to be sure, we can erase the DTBO. Oh. It should always have the slot. Weird. Alright, and that should be it. So we should now be running the postmarketOS on device installer. Oh, this is not looking good. This phone seems to be very unhappy. This is really not what I want for a stream like this. This usually means that the device is booted, but was unable to set up USB gadget properly. Very odd. Well, I don't imagine we will see much come from this. Okie doke. Let's see. Perhaps we can just try a more normal postmarketOS install. I do know that the device info file does not specify the command line options. So the PM Bootstrap initramfs will actually not output the boot logs to the display because, well, I mean, on a device that's shipping, you don't really want to necessarily seal that, so they just have a boot splash. However, as we are developing, we do want to be able to see that, and there is a command line option that we can pass that will disable that. I forget the name exactly, so let's see. I know the Poco phone F1 has it set. Xiaomi Beryllium. Here we go. PMOS no output redirect. So if I run a boot img on that boot image, oh, it does actually have the command line option. So something more is going wrong here, I suspect. We will have to force reboot this. device. Ah, well, we're on the B slot. That would definitely be causing those issues. Because that isn't where we flashed the boot image to. Let's reboot again, shall we? And here we go. Mount subpartitions. So it looks like it's currently attempting to mount subpartitions and not doing a very good job. It started with SDB. I think it will get to SDA eventually. So it looks like it's going through every single partition on the device and checking for subpartitions. That isn't really ideal. So we will leave that going, and at the same time, perhaps we can do a split on device install. I did try and have a go at the on-device installer last summer, but back then, if you passed -- split with on-device, it would actually fail. There was some issue with setting up the loop devices, so when you're doing a split install, it sets up a boot loop device and a root loop device, whereas when you're doing an subpartition install, then it will just create the one, and it was not creating the extra one and then trying to use it. Some pretty odd behavior. But I think that has since been fixed, so there we go, look. We've got our boot and root. So this boot isn't actually like the Android boot image or... Oh no. It hasn't been fixed. That's a bit of a shame. Well, let's see, did it delete our existing images? Perhaps not. So what we can actually do is unpack the subpartitions from this boot image. And we'll have to check how to do this. Right. Let's have a look. I think I have a script somewhere that does this. Yeah, my friend was working on Manjaro ARM, and he wrote a script that can take the PinePhone image, which is the same. It contains two partitions, and set up the loop devices for it. So he uses part X, so that's what we can do. We can go part X dash A. Uh-oh. It looks like it wiped it. Oh dear. Oh. Subpartition not found. That's a bit of a shame. Well then, I'm not sure what we should do now. I can perhaps. Well, at least it has already done the install. Only has to fill out these block devices. We can oh, it's done. Uh-oh. Let's see, I put a mount right now. Oh. Dev tempfs. No. What's here? Android sparse image. That looks a lot like our rootfs to me. Ah, yeah. 0, P1, P2, P3. That's 3 subpartitions. I wonder what they are. Well, that's not very useful, is it? Loop 0, P1. No. P2. Well. What's over here? Hmm. The alternative is, of course, we just go back to a standard install. Sorry if you can hear the train in the background there. Yeah, let's see. So here we go. Android oh, of course, we have to convert it to be not a sparse image. Yeah, SIMG to AMG, and we will put it just here on dev rootfs. That was quick. There we go. This looks a little bit more like a an image, I suppose. 3.8 gigs, lovely. So now we can run sudo part x-a on dev rootfs. And there we go. I guess it will be loop 1 p. Let's see if file tells us anything about those. Nope. Loop 1 p1. Oh. This ain't looking too good, is it? Maybe PM Bootstrap is interfering. Dev loop 3. Okie dokie. exe4. Nope. This just ain't what we want, is it? Oh well. Oh dear. Okay, well, in that case, I guess we won't be trying out the on-device install today. We'll just go for a normal split install. Oh no. Yes, of course, after running the on-device installer, it permanently breaks the PM Bootstrap environment until you run zap. What do we want to do? HC, I think -m. Yep, get rid of the ch roots. There we go. Now we should have a little more luck. I'll be cheeky and type my password in now. And I will return as soon as I fill up my glass of water. All right. Well, this has been a rather boring start, but hopefully it will pick up a bit once we get Gnome up and running. It's been quite a while since I've used Gnome on this phone. It was actually it's possible I haven't used it since before we got hardware accelerated video working. Possible. So this will be fun. Oh. These scripts are quite amazing, despite the unfortunate bugs that we hit. It's really impressive what PM Bootstrap is able to do. It really takes a lot of the hassle out. I mean, imagine if you had to build the routerfs yourself, install like device specific packages. I mean, there's so many configuration changes that makes all of this stuff actually usable on a phone. It's quite incredible. Tunis, this is VS Code, Visual Studio Code. I started using it a few years ago, and it's just, I mean, it is made in Electron. It's a little bit heavier than, I mean, you'll like get it, but you know, it's a very good IDE, and it's very programmable and doesn't try to do everything by default, which I quite like. All right, so here we go. We've got our standard install done. We've also exported the image, so we'll head over to the installer. And in fact, you know, I think I'll wipe the DTBO partition, so we can't boot TWRP, which sucks. And I don't think I have a backup. Oops. I was very well prepared, as you can tell. So what we'll actually do is just flash the root of master data again. Uh-oh. Any idea why making USB controllers work with mainline is such a pain? Are you talking about the USB controller like on the device or on my computer? On the device, I mean, well, the USB stack works, but the part that does the actual, like, I guess, detection and... Oh, right. Yeah, I don't own a OnePlus 3, unfortunately, but, yeah, so the actual, like, USB controller works, but being able to automatically detect, like, host or gadget mode and do voltage configuration and, like, output 5 volts when in host mode, all of that kind of stuff doesn't really have support on mainline yet. I mean, it's there. Certainly some devices do, of course, but most phones don't. Okay, we are flashed, so now what we can do is we can head in here, and we do have a kernel built already, although I think this branch, like many other things today, might be a little bit broken. So let's check out the STM845 stable branch. Got some work in progress commit here, but this shouldn't affect things. So we will make def config and then build. One of the things that we did for this, for 845 mainline devices, since we've now combined the OnePlus 6 and Pocophone F1 kernel forks together into the one branch, we need a lot of config options, of course, and rather than go touch the ARM64 def config, so this does get updated with kernel releases, and it's basically a catch-all, but rather than add all of our options here where it would kind of get in the way, like I've done that before, and what happens is you go to rebase on a new kernel release and you get hit by a ton of conflicts in this file, it's a real pain. So what we do instead is we just create this config fragment, which just only contains the options that we need for our device, and it's designed to basically get merged in with the default config. So we have, you know, the displays, Synaptics RMA4. Of course, the device-specific things are all built as modules, so that way we aren't building in stuff which isn't going to get used. So with this, well, as you saw, we just do make defconfig stm845.config. The kernel merges them together, and then it generates a .config for us, so makes it really, really easy to maintain. And it means that we benefit from all the changes to the ARM64 dev config. Luckily, I have Ccache enabled, so this shouldn't take too long. That was very quick. Yeah, USB devices do support XCon, or like external connector, which is where you can use a GPIO for detection. I remember reading into the documentation for that, and you can have a voltage. What is it? There's like a VUSB pin and an ID pin, and depending on the combinations, adjust like what mode the USB controller should be in. So I think when the ID pin is high, that means go into gadget mode. The VUSB pin is high, then you go into host mode, and if they're both high, then it does something else. I think maybe it does like we're powering the other device, but we're also in gadget mode. Honestly, it's been a while since I've looked into it, so maybe don't listen to me. The kernel documentation is there, and it's not bad. However, most modern devices, I don't know about the OnePlus 3, but certainly the OnePlus 6, whilst there are some GPIOs that change state when you plug in the USB connector, I don't think they're meant to be used like that. What actually needs to happen is you need a driver for the Type-C chip, because that piece of hardware actually does all of the early setup and figuring out what mode we're in. So you need to talk to it, and it will tell you what to do, pretty much. Of course, we also don't have support for, like, when you're in host mode, you need to do 5 volts out, and we can't do that yet. That regulator isn't hooked up. So it's definitely something to put on the list, because, I mean, unfortunately the OnePlus 6 only has a USB 2.0 port, but something like, say, this OnePlus 7 has USB 3. So if we can hook up mode detection there, then you can get like a USB-C hub. In theory, DisplayLink could work, which would mean external displays over USB. If it doesn't, and your device can mux DisplayPort, even better. And you know, a lot of Android devices, if they get mainline, they can be like, could be a pretty powerful device. Certainly something that you could slap into like one of those old lap dock things where some like really old Motorola phone had a lap dock. So you set the phone in it, and then it turns it into a laptop, basically. There's no reason why modern devices couldn't do exactly the same thing. And USB-C certainly allows that, so getting better USB support on mainline would be amazing, you know? I mean, I've seen Martin hook up a Pine phone to a display and a keyboard. That's really cool. I like that they've made that a possibility. Full-fledged computer, exactly. There's no reason why you couldn't hook up a 4K display, gigabit Ethernet, and a mouse and keyboard to your phone. certainly the newer ones. I mean, the OnePlus 7 has a 1440p 90Hz panel in it. They certainly have the horses to drive it. Just lacking the I/O and the software really. Now then, this mkb command will set up our routerfs, and we, by not specifying a path here, the initramfs will use dev.sta17 as root, fingers crossed. So now we should just be able to flash the boot partition and fast boot reboot. Here we go. We are booting into postmarketOS. It's possible that this will... Oh, we have a cursor. There we go. The exposure's a bit screwed up. Let's just fix that real quick. Oh. And the exposure lock off. Yeah, this camera is not great, is it? Oh. Okay, so it's built, it's done, but the kernel modules that got installed to the routerfs, including like our touchscreen driver, don't match the kernel version that we're booted, because we're booted my kernel that I built out of tree. So what we need to do is install our kernel modules. Luckily, I have a very useful alias that does all of this for me. All of the commands and stuff that I use for all this development are available on GitLab. I'm not sure if they are linked in the description, but I will in fact go add them there now before I forget. No, there's a link to the GitLab group, but not to my actual tools repo, so here we go. Tools. All right, so down below should be a link to the PM tools repo. Here we go. So there's a big view of the very low res webcam. So what I'll actually, all right, switch back here. We'll run make install modules, which will automatically install all the modules. Before we do that, I'll run this alias. This function basically connects the device. Oh, of course. We have a different username. Oh, okay. What I'm gonna do is just edit my SSH config. So I have a host setup for PMOS. Here it is. So there you are. So this host basically has the username configured, has the IP configured. This is the IP that the initramfs sets up for it during boot for USB gadget. We disable this, and this line by setting the username host file to dev null. So you know when you connect to a device and it says like, would you like to remember this device's SSH key or whatever? I forget the exact message. When you hit yes, it keeps it in the known host file. Obviously, when you are regularly wiping the routerfs, that means this device gets new SSH keys every single time. which means that every single time I do it, I have to go edit the username and host file, delete the entry for the device, etc., etc. It's a real pain. So set it to dev null and it doesn't get saved, and that's that. There we go. So this just does a few useful things. Last part we don't care about. There we are. So basically this is meant to set up USB networking, but that doesn't seem to work right now. What it does, which is important, is it disables the sudo password. So sudo will work without a password, which makes running this alias useful. Otherwise, this asks for your password about 6 times. So it does quite a lot of stuff. So it uses, it runs, uh-oh, that's not good. We ran out of space. Oh dear. Today is not the day. Lib modules. Okay, so yeah, it runs rsync, copies of the kernel modules over. Oh no, still no space. This might be a little bit of a pain. So we need to run. So what happened is it flashed the user data partition, but the actual rootfest image is of a fixed size and it doesn't automatically grow to the size of the partition. We need to do that manually. And of course, you cannot do that to a mounted partition. Oh, apparently you can. Well, that's helpful. There you go. There's a bit of a better view. Awesome. Finally, a break. So we'll reboot so that it can get the new size. We'll make sure that it's grown, and then we'll copy modules again, and then we will have a touch. Obviously, these issues aren't the kind of stuff that you hit if you're just trying to test this out for yourself. These are the woes of developing. So here we go. We've got all 100 gigs of free space now. So I can run and make install modules. They will all get copied over. We got loads of space. And we'll be good to go. So yeah, there's an interesting tool called Box86, which I did talk about earlier. For anybody new, it's basically just it's an x86 compatibility layer for AH64 devices, ARM64, and it looks like the OnePlus 6 is currently one of the most powerful mobile devices that would be capable of running it because it has mainline. So we will reboot again so our kernel modules get registered. With Box86 you can even run Wine on it, which is pretty amazing. Unfortunately, I wasn't able to get much up and running. I did have a bit of a go a while ago. There we go. So now we have touch. We can enter our password, which is 234. Oh no. And here we are. So I'll turn the brightness down a bit so that it's a little more viewable. We will turn up the display scale. We're already at 200%. Yeah, so Gnome is honestly pretty usable, although we don't even have Firefox. Let's get connected to Wi-Fi. I'll just do that real quick. Oh no. There's no Wi-Fi. What's happened here then? Remote proc is up, but we have no Wi-Fi device. Ah. It looks like we need to start up these services. Oh. I suspect they are, for some reason, only automatically started on Fosh. Here is the Gnome welcome screen trying its best. Let's see. Can we get rid of this? English UK. Ah, it was waiting on Wi-Fi. Lovely. Here we are. We should be on Wi-Fi promptly. Ship account set up. Start using postmarketOS. Okie doke. There we go. Wi-Fi is up. Everything is up, so now we can APK add Firefox. You know, despite not at all being envisioned as a UI for phones, Gnome is surprisingly usable, I have to say. I mean, certainly with a larger screen, it is not bad at all. Except for window resizing, which, I mean, how are you meant to grab these corners with a... There we go. Alright, let's see if we can fix this exposure. Oops. Perhaps we want to bring this a little bit closer. Oh, that'll do nicely. Alright. Firefox is installing. And it's done. And now we should be able to see it up here. We don't have the Firefox mobile package, I don't think. But we can head over to YouTube and check that the videos are playing properly. Oh, no, thank you. Yes, so we don't have touch scrolling. We do have adverts. UK specific adverts. this probably was not the best choice of video, as of course there isn't much movement, but yeah, you know, this is a pretty good experience. Okay, so let's see if we can install Box86, shall we? I'll bring this over here. That's quite a fast boot. Yeah, it's impressive. I mean, UFS is pretty fast. The device is pretty fast. It's a pretty good experience. So I do believe they have an app image. Oh, I think we'll have to go ping someone who knows. Well, whilst we wait for that, let's see. Does Steam run on AO64? That's Steam Link. Damn. What's on here then? I spent way too long trying to get Minecraft to work once. It was not very good, unfortunately. Ooh. Shame this is all for Debian, huh? Perhaps we'll save this for a different stream. Okie doke. Let's see, looks like haptics are gonna work. Oh yeah. That's nice. So, well, bit of a rough start, but here we are now. Now, there is actually a bit of a bug with haptics. Every time the haptics go off, we get this haptics busy after 5 retries. So why don't we have a look at that? Now the haptics driver is in drivers, input, misc, PMI 8998 haptics. This driver is pretty much just based on the downstream Android driver. So there's no public documentation on this haptics hardware. All I had to work with was the driver and downstream, which is reasonably well documented, but there's a few kind of quirky things. So like there's some options that you can pick, and you have like opt 1 through opt 4, and there's no documentation on them. If you look in the DT binding file for it that documents how you do the device tree node, it just tells you that the options are there. That's it. It's not very useful. So haptics busy. So this happens when we call is haptics idle, which is meant to return, well, get the state of the haptics, I suppose. So it reads the status reg. If we look up here, bit 1 is the hap busy bit. Bit 3 is the short circuit flag bit. This bit gets set when the short circuit IRQ is triggered, and the expectation is that in the IRQ handler you reset that bit and all is good. The short circuit IRQ seems to be dual purpose, so it's also a way for the haptics device to make sure that the host hasn't crashed, that your kernel is still running, because the last thing you want is for your phone to like lock up whilst it's vibrating, and then it just keeps vibrating because the haptics hardware is separate. So every 50 milliseconds, I think, it triggers a short circuit IRQ that you have to handle, and you have to clear this bit, and if you don't, then it will stop vibrating. So it reads the status register, and it checks the hap busy bit, and if it's set, then we return true. This function was pretty much just copied from downstream, and of course the way that they use it will be slightly different, hence why this issue doesn't happen there. It only happens here. I also ended up rewriting a decent amount of the behavior because obviously rather than, well, mainline does things differently. So downstream actually exposes the haptics as an LED because they have fairly similar properties, but obviously that ain't gonna fly for us. So I reworked it to use the force feedback API, which is much more sensible. Yeah, so it's all a bit different. Where were we? Right, so it checks the hap busy bit, and if that bit is set, then we're busy, so we're not idle, so oh, that's important. If we're not busy, then return true, of course. If the busy bit is set, then it goes through this for loop 5 times, checks the play mode. Okay, so I think the way this works is if you're in direct play or PWM, then return true. This should not be inside the for loop. This should actually go right up here at the top. That makes absolutely no sense. Okie doke, so we read the status reg again, and we basically repeat what we did up here. That's a bit silly. So I think it's important to first of all know at what point do we call this function. Right, so haptics module enable. This will actually enable or disable the actual hardware itself. So if you write a disable here, then it will just stop doing whatever it's doing, as far as I'm aware at least. And of course, if you're enabling it, then yeah, so you either set the enable bit or you write 0 to it. When you write 0 to it, you disable this bit. By doing so, really this should be like not bits 7. Although there are no other bits in the status register as far as I'm concerned. As far as I'm aware. Where else do we call this function from? We call it here where we write the play mode. So we can't set the play mode if the haptics are busy, which makes sense. So, unfortunately, I gotta say the Gnome lock screen looks a lot better than any of the others that I've seen. Here we go. I mean, it's fairly smooth. It's certainly smoother than Fosh. Which makes sense, as Fosh is written in ETK3. Here we go. So, basically, every time we vibrate, we get this error. So if I run dmessage -w to watch, and then we open up a new shell, and we do ff test, which is just for testing the vibrator. So it's vibrating now. When I hit Control C, it stops. And you see when it stops is when we get this haptics busy error. So I would guess that that is being called from here. So we should kind of go through the call chain really. So this gets called okay, so the way it works is ff-test runs on dev input event 0, which is the input device which we use for our haptics. So that's what we create here. We create an input device, we give it a name, and we say that it supports force feedback, specifically force feedback rumble. And then we register this callback. So this callback happens whenever we get a play command written, essentially. So we get given this ff effect, which user space actually gives us. And we do some dodgy maths. This definitely needs to be improved to set the strength. It actually sets the voltage that we give to the actual actuator that goes back and forth. So obviously low voltage will mean a weaker vibration. Although on Android they just always use the max voltage. You don't get any control. And they only change the duration, which is a bit naff really. I hope other Android devices don't do that the same way. So then we call haptics write vmax to update the voltage, and then we schedule the work function. So that schedule work will actually cause this to be called in a different thread, because obviously we need to return from that input callback handler. We don't want to be running in that thread because that would just be wrong. So we process work to actually handle the haptic state change. So here we read the whether or not we're meant to be activating the haptics, and then we just call haptic set to either enable or disable them. Oh, there it is. So this will lock the mutex because it is technically possible if you called play like twice really quickly, then this function could be running multiple times concurrently, which would not be very good. So we have a mutex to make sure that you can only be setting the state once. That came out wrong. You can only be setting the state like once at a time. You can't have if this function is running multiple times, haptics might do weird stuff, potentially break, because this is obviously not atomic. We could have like bad things happen basically. So this is what we call module enable for an enable, but as we noticed a second ago, it doesn't happen when we start vibrating, it happens when we stop. So that probably happens here. So we call module enable false, which will then call is haptics idle, print this debug message, and then disable the module anyway. So I think the question is, do we want to be doing this anyway? This behavior is a bit weird. Surely is haptics idle should return immediately the current state rather than wait for the haptics, although it doesn't do any waiting anyway. I do believe that it would be fine to get rid of this max retries altogether. We don't even use this macro. I think this function is a little bit different on downstream. I think it might have been one that I meant to finish up, but evidently forgot to. So what we can do is get rid of all of this. And clean it all up. There we go. So now what we can do is, we'll do this in a new shell actually. We can build a new kernel. Oh yeah, this is of course just a make alias. So we use clang, set the cross compile prefix, set the output directory, architecture, all this fun stuff. KDE lock screen looks better. Yeah, maybe we should check out KDE. I'm not actually sure if KDE is one of the options for. There we go. Let's see. Yeah, it doesn't look like KDE works there. So we have Plasma Mobile, but Plasma Desktop, of course. Yeah, I have used this before. It was nice. I'm not sure it scaled so well for mobile, but you know, let me know if you want me to check it out. You could always check out Kodi too. That could be fun. Right, so here we go. We built our kernel. We got this warning because we didn't delete this counter that we don't use. We'll just do that now, otherwise I will definitely forget and get told off for it later. You know, it's a real shame that this keyboard just doesn't scale properly. Yeah, there you are. Bosch has actually exactly the same issue. I mean, this phone is of course taller than 16:9, which I think contributes to the problem. But the keyboard is just not tall enough, which is a bit of a shame, really. All right, so we can run. I actually had that command in the history here. There we go, mkb, and now I have this this useful script function atflash, which will pretty much figure out what state the phone is in, if we're booted in postmarketOS or in TWRP, or already in fastboot mode, and it will flash a boot image that we give it and then reboot the device again. So look, it's actually installing the reboot mode package for postmarketOS because it was missing. And then it will use that to reboot to bootloader, like you just saw there. Flash the boot image and reboot. And I don't even need to go fiddling with, you know, buttons and holding down button combinations to get to fastboot mode, all that kind of stuff. It just does it all automatically, which is very sweet. And here we go. Uh-oh. It's obviously a big time saver too. I could take that time to explain what it did instead of having to manually put the phone in fastboot and type all those commands out. Alright, so we are now back into the device. We can... Oh, we probably don't have Wi-Fi again. You know, let's check this first, and then we'll go fix the Wi-Fi not starting automatically on Gnome. It does on Fosh, so it's probably just UI specific. Here we go. So now we can rumble, and it stopped rumbling, and we didn't get an error anymore. Alright, so I will call that fixed. Yeah. We'll play by the rules here and check out a new temp branch. Haptics, fix, haptics, busy error. The is haptics idle function was doing some weird things. Make it just return the state and not wait for haptics to be idle. There you go. Oh, this is the problem with long branch names, isn't it? Alright. The wonderful thing about... Whoa. Where are we? Here we go. Here we are. The wonderful thing about GitLab is when you push to a new branch, it automatically gives you a link that will let you create a merge request. Oh, nuts. We have this audio commit in here too. So we'll have to get rid of that real quick. There... Ooh. Should be another copy of this commit. Somewhere. I think it's fine. We'll drop that commit. And then force push to our branch. Now reload this page. There we go. So it automatically fills up the description with the commit message. Haptics now doesn't print any garbage to the message unless something bad has actually happened. And there we go. So we'll open this PR. So we're trying to keep this SDM845 branch, the stable branch, kind of neat and tidy. So using merge requests rather than just pushing and stuff like that. Although we haven't been very good at it, it's definitely something that we should work on. Yeah, it basically means we can keep it neat. We only put stuff there that we know works, and it's the branch that we'll use for postmarketOS and hopefully Manjaro ARM releases too. So keeping it tidy is very important. And that should be that. So I'll let Joel take a look at that MR when he gets a chance, and we'll be good to go. Wow. I can't believe we're almost at 1 million commits in the kernel. It's pretty incredible especially given the history only goes back to 2.6. Now then, let's head over to PMA ports and take a look at the device repo. We got this MR the other day, which I still haven't tested out. Need to do that. So this will this UDEV rule tags the haptics device for feedback D. So that means that feedback D will pick it up. That's the daemon that does haptics in Fosh. So the next release, haptics will work in Fosh out of the box, which is really, really cool. I am absolutely chuffed that this driver works as well as it does. Alright, so I think it actually is in here. So yeah, this post install enables these services. ARM TFS does get enabled by default somehow. It has been a while since I looked at this, but this should get installed. I wonder why it wasn't. Okay, let's check in Enchilada. Yeah, so we have this extra little Bosch subpackage which just contains this one file, and this just overrides the scaling so that Bosch is usable. It's 2.0 by default, and for us that's just not enough. It means the keyboard is too small and like it's just not too great, so we override it to 2.5. Yeah, so let's see. How do we know if we have this? We did pick non-fee from her, otherwise we wouldn't have Wi-Fi at all now. Alright. Let's see, let's get rid of this shell, we don't need that anymore. And let's run APK list. Grep. Here we go. So we have this SOC package installed. That means this post install should have run. We can check if we have these feedback D rules. They do currently get installed to every single UI, no matter what, which, I mean, it doesn't really matter because, well, you might switch UIs at some point, and yeah, I don't know. I think it's fine, it's just this one rule, so user lib udev rules.d. There it is. Excellent. Perhaps we should try out Fosh now. I think I'll have to come back to this issue, as I really don't know what could be causing it. Alright. Time for another PM Bootstrap in it. And in fact, I'm going to change the username back to user because consistency just makes it all a lot easier. And we'll pick Fosh because we want to test haptics there. Yeah. Here we go. There was actually a bug yesterday that appeared because of an update to eLogin that prevented Fosh from starting completely. So that's That was a bit of a pain. It was to do with dbus endpoints missing, I think, or some dbus names. But thankfully that's been fixed, and it should be back now. Well, they got merged upstream to the Alpine repos, so we should be seeing it here now. Whoopsies. Alright, we can head over to the log. It's a little bit annoying that it builds the initramfs so many times, especially as this takes a really long time. But yeah. Wow. It's been really amazing to see so many people on Twitter really enjoying that we're able to do this now, and that, you know, we're able to run Linux on phones. And especially, I'm really glad that on the OnePlus 6 at least, it's possible to dual boot really, really easily. You know, I think being able to check it out and get used to it, and of course, provide feedback to the software developers, because, you know, a big part of the effort now is in the kernel and getting the hardware actually supported at all. But it's all very well having a phone that can run Linux and has like all of the hardware working if at the end of the day it just isn't very usable. Oh, that's the wrong shell. Yeah, so having proper suspend, being able to receive notifications on time, all things that are really important in a phone. And currently it's just definitely lacking from mainline, although some of that is kernel side work. And of course, like Fosh is still very new. I'll admit it is far from the smoothest experience. There's definitely progress to be made. Lomiri is really nice on Manjaro ARM. I'm hoping to make that available as soon as I get some of the last few issues resolved, but it has proper hardware acceleration. It uses Mesa. It runs like an absolute dream on the phone, except like XYLand is a little bit broken. So if you want to run X apps, they just don't really work properly. The open store is not there on Manjaro anyway. Of course, it's on UbiPorts, but that means a lot of the mobile apps developed for Lomiri just aren't available out of the box. I hope that open store will run on Manjaro ARM. It may already. I only had a quick look when I was playing about with it, and I couldn't find it, but certainly being able to get all those apps like teleports and fluffy chat, as well as everything else that runs on there, would be very, very nice. Once Ubuntu Touch moves to 20.04 base and they update all their base packages, hopefully their mainline will also work. So currently Lomiri works on Manjaro ARM on the phone, but not on Ubuntu Touch, which is funny. But yeah, hopefully we can get that working too, because, well, yeah, then we can get OpenStore, we can get their OTAs, and it'll be a more stable experience. But whereas Manjaro ARM is obviously a lot more kind of bleeding edge. Right. it is time to flash the kernel. This just runs reboot mode on the device, but I have to do it myself. There we go. Of course, this is just an ext4 image, and so Fastboot complains because it is not a sparse file, which is fine. We could technically grow it to like 30 gigs and then convert it to a sparse file, and then it would go back to just being it's like 3.8 gigs or however big it is, and then we can flash it. And then when you boot the device up, you'd have 30 gigs of space, but I'm not going to bother. So the great thing about this is we're flashed. We can keep our existing kernel. And we can just, reboot in theory. Yeah, the fast boot tools are not too great. And now we should boot into flash and we will not have anything working because, again, we're missing kernel modules, so. Gotta go to this again. This is why. Should always use the same username. There we go. Only 200 megs of free space, so sudo resize fs, resize 2. I forgot the command name. Oh, what? I definitely picked 1, 2, 3, 4, right? That's not good. What's happened here? I think I've been hit by this before. On Manjaro ARM, sometimes when I SSH in, it would just tell me the password is wrong, even when it definitely isn't. And then like rebooting, it would work. Try this, shall we? Unbelievable, to be honest. How could this happen? I guess we'll just have to do it again. These are just the things that happen when you try and stream, aren't they? Wow, we've been going for almost 100 minutes. All right. Maybe we can take a look at the oh, I'll tell you what we need to do. We need to make a new, oh, he's done it again. You know, I bet I did 2134 as the password. I bet that's what happened. I made the same mistake twice. Oh dear. Alright. That's fine. We will have to reboot by hand. I think once we test this, I will check out the what am I saying? once we get this working, I will make a new release and we'll post on GitHub, because currently the latest one uses the old device-specific kernel package, which means that if you update your kernel, if you update your device whilst it's booted, then it will download the new kernel package, delete the old modules, install the new ones, and that's it. It doesn't know how to flash the kernel yet. That is something that we need to add to get proper updates to work. And because the kernel packages are different, it will fail, and then when you reboot, all the kernel modules are gone, and so your device is basically unusable, which obviously sucks. So we are done. We can flash again. And then we will be good to go. Or hopefully the last time. I will need to grab a copy of the Android 10 DTBO partition, because I believe I wiped it, which means that we can't boot into TWRP to actually test the zip that we'll build in a minute. In fact, we can do that right now. Android enchilada zips. Here we go. I think this is Android 10. There's two numbers in these, and none of them seem to make much sense. Alright, so let's go and extract the payload here. Yeah, update engine is weird. The way that OTAs work now is just a bit of a pain. Here we go. So now we can go in here, and now we can run Python. This tool extracts the partitions from the payload so that we can flash them. So we just gotta wait on the DTBO. Whilst that's happening, we can head back here and hopefully have the correct sudo password this time. Oh dear. There we go. Oh wow, it does actually do fully online resizing. Amazing. So now we can just run our cheeky alias. That will use rsync to copy the modules across, and then copy them over to /lib for us. There we go, and now we can pmos-t, because we haven't enabled passwordless sudo now, so we'll reboot the phone. And now we'll have touch. Wi-Fi works out the box on Fush. Again, I am not sure why. It didn't work in Gnome. Weird. Here we go. And haptics work. I'll hold this up so you can probably hear it. Or not. No, I don't think that's coming through, but yeah. You can trust me. We got haptics up out the box, which is very cool. So yeah. No Wi-Fi again. Ha. So yeah, maybe this post install script broke with this PR somehow. Very weird. Oh, we'll run the setup script. Okie doke. Oh, but there's Wi-Fi. Personally, I find having haptic feedback when typing makes using a keyboard on a phone a lot easier. Let's fix that exposure. There we go. Yeah, I mean, without haptics, it's kind of hard to tell if you hit the right button. Sometimes you can hit 2 keys, and when your phone vibrates, every time you hit a key, you get 2 vibrations, so you can tell. It makes things a lot easier. Oh, we're not on Wi-Fi yet. There we go. Sweet. Let's see if we can find this live stream. Why not, huh? Oh yeah. So the time is wrong right now. We can restart the NTPD service to fix that. That's another thing that will need to be looked at, is the real-time clock in this phone is a bit finicky at best. Finicky is probably not the right word. So we have the driver for it. Damn, what is the name of the command for doing clock stuff? I do not remember. For some reason, on some Qualcomm SoCs, the real-time clock is read-only. They just don't let you write to it. If you try and write to it, you get a write error. The driver tries to write to the hardware just says no. So I did actually see a patch floating around which is a workaround for that, which tricks the hardware into letting you write to it or something, which is pretty crazy. But yeah, basically the real-time clock keeps the time since the phone was built relative to epoch 0. So this particular phone is what, like 15 months old now? So in fact, what if I just oh, that ain't gonna work. Basically, if you read the real-time clock, the date that it will have will be 1971, around mid-year, because yeah, I mean, relative to, what is it, midnight, 1st of January 1970, that is how old the phone is. And you can't update it to be today's date. It doesn't like it. So that's what you get. I have no idea how Android works around this. It's a bit crazy, but yeah. You can do some maths and keep like a hard-coded offset value. So you can still use the real-time clock, but you need a per device offset that you basically add to it. So you basically you read the real-time clock and you read epoch now, and you subtract the real-time clock away from it. And then on boot, you can add that value onto the real-time clock value, and you will get a pretty accurate reading of the actual time now. So you basically just offset the real-time clock as needed. Yeah, that wasn't a very good explanation, but there's definitely some stuff to do for the RTC for this to be a properly usable device, which is of course what we are aiming for. Now then, let's see. So this stream is called More Linux Mainline. Oh, there we go. We are live. So yes. You can indeed watch a live stream on your mainline Linux phone. That is pretty cool, huh? In fact, we can even turn it sideways. Haha. Awesome. If a little dark. Uh-oh. I can't get out of full screen. Okay, I think I'll have to kill that. Alright, so there we go. It's a pretty usable experience, I have to say. I mean, certainly for what it is, and given the early state they're in, so yeah. Let's go and make a flashable zip. We've already done everything we need to, so we can just run this. And it will do it for us. Okay. While this does that, let's head back over here. We're done extracting, so we can reboot into the bootloader. Oh, oops, I did not announce that I was live on Discord. Well, you know, we've done alright. I suspect I will probably stream again next Thursday. And try and make it a bit of a regular thing. So, you know, if that's something you're interested in, yeah, I'd like to make it happen. So we're in the bootloader. We're currently on the A slot, so we want to switch to the B slot. This alias is just fastboot selective B. So switch to B slot, DTBO, flash that, and now we should be able to boot into TWRP 3.5. Our flashable zip is already Let's see. Wow. We got the USB disconnect, so that's good. That means it didn't get stuck in fastboot mode. Despite what the screen may say. Oh. Sorry, that was just the webcam view. I'll mute those, oh dear. OBS has stopped responding. That isn't good. Oh, there we go. Right, I'll mute those notifications. Looks like our phone is stuck. Despite what I thought. Damn. Let's see, what else might we want to flash? Probably want to flash vendor and system. Here we go. And I'm going to grab some more water whilst this proceeds. Oh, sorry about that. This is a big system partition. Huh. Not a sparse image. That's really odd. Well, hopefully it flashes. I've never seen 6 parts. That has to be pushing it. Here we go. So hopefully we'll reboot back to bootloader, and then now we should have everything we need for TWRP to be happy. Fingers crossed. I think we're out of luck. Oh gosh. Oh man, well, perhaps we should hmm. Do I have an Oxygen OS 9 zip? I thought I did. Maybe this is Oxygen OS 9, in fact. Let's try v3.3, which is the one that works for Oxygen OS 9. I think I'll prepare some more things for next week. Of course, I have a OnePlus 7 to work on. So, you know, I mean, of course I want, hey, it worked. Right. I'd love to get this OnePlus 6 release, so we'll do that now. And yeah, so I don't know, definitely leave me some feedback on what you'd like to see me do. I think I have a list of some things. See if I can copy that. Although Vim clipboard is not very nice. I'll have to remove these numbers, eh? There we go. I bet YouTube won't be happy with this. Oh, well, oh, yep, nope. Well, here's a list of some things. If you want to see me work on some stuff, some more kernel development or more packaging or trying to run games on the phone, Manjaro ARM stuff, yeah, just kind of let me know. I mean, the notification LED is something that we'll need to work on at some point. There's this tri-state switch, which so Sailfish OS, which some of you may have heard of and or used. For the OnePlus 5 and 6, there's a daemon. Oh, and the OnePlus 3 even. A daemon that has been written for it that lets you still use that switch to switch like ambiances. So if you don't know, Sailfish OS ambiances are basically like pre-configured themes, ringtones, and include stuff like the ringtone volume and all of that. So you can have like a silent ambience, a work one with the ring of volume at full, one that's just on vibrate. So you can get exactly the same functionality that you would normally use on Android with that tri-state switch, but you also get to switch themes with it. So you just get a lot more freedom. I think it's really, really cool. Something similar for postmarketOS or, well, any mainline distro would be very nice. The way the switch is actually hooked up in hardware is it's 3 GPIOs, and which one is high tells you which state the switch is in. Make sure you push the right zip. Oh no. Okay, so the other phone is of course the phone which is running the webcam. So we need to make sure that we don't try and do anything to that. Where was I? Ah, yeah, the TRISO switch. So yeah, it's hooked up as 3 GPIOs, and I originally, based on some work that my friend Jamie or Deathmist did, where he basically just hooked it up as like GPIO keys with a big debounce value. So when you change the state, it could do a macro key or whatever. But when I submitted my patches to the kernel, I got an email um, from, sorry, the patch got, I guess, reviewed by someone, and they were like, what is this? Why are you implementing it like this? And they weren't very happy with it. And they have a point. It doesn't really make sense to have it be 3 keys, because that isn't what it is. It's a tri-state switch. So firing keys just doesn't really make sense. So it looks like we'll need to write a kernel driver for it, which is quite exciting, because it'll be an interesting project. Finding out the most sensible like input device API to use, and then we can write a user space daemon to handle it, and we'll be away. And then we can package that up for Manjaro, postmarketOS, Arch Linux, Debian maybe, and use that to basically do what it does on Android or whatever else really, because why shouldn't it be configurable? Yeah, of course, these things take quite a long time to develop, and who knows when I'll have time to work on that. So actually show you this installation live now that I have a camera. All right, I'll tell you what, on here we will watch the logs and we'll see it flash. Yeah, I figure anything that I'm going to be doing on a stream is kind of for it's for other people to watch. So I'm kind of open to working on stuff that wouldn't necessarily be like top of my list in terms of functionality. So like the TRISO switch is it's a really cool thing, and I can imagine writing a driver and daemon for it would be quite interesting, and something that people would enjoy a lot more than like me debugging some really boring issue like suspend not working or whatever, which takes a lot longer. There's a lot more like doing nothing in the middle, waiting for a device to go into suspend and like getting logs and all that kind of stuff. It just isn't very interesting to watch. But yeah, so yeah, basically just let me know what people find interesting, and I can work on that. And of course, everything is open source. Everything that I'll be working on will be available on GitLab, and I'm absolutely welcome anybody who's interested in contributing or getting involved, or opening issues, providing feedback. It's really, really useful stuff, because all of that, if well, you don't have to be smart and know programming, and like not saying that people aren't smart, of course, but you don't have to be a computer scientist to test out software. And often testing is the thing that like developers find boring. I want to be writing code. I don't want to be sitting down and testing every little thing to make sure it works. But it's yeah, it's pretty free for anybody to to go test it out and give feedback. Alright, install is done, so let's reboot, and here we go. We got touch. No Wi-Fi. Yeah. That is a real pain. I really wonder why this post install script doesn't get to run. I said yes to non-free firmware, right? Oh, let me just fix this brightness for you. So let's see. Yeah, it's installed. Can we reinstall it? Will that work? Oh, of course, we don't have any internet, so there's we can oh dear. All right. We set it up. Disable the sudo password, and it copies SSH keys too. That's all we care about. So this sets up USB networking on the device. It adds a new route. So it adds a new route via, this is my host IP on RNDS, and then adds the DNS entries so that the device can resolve host names. And then on my host on Fedora, you have to run these obtuse commands, which make it work. Gosh. Where were we? There we go. Okay. Oh. Yeah, so they just aren't in the run level. Okay. Let's see. Of course. There is a big dependency chain with PMA ports. So removing this package is not really feasible. I guess we'll have to go and ask the people. Since the haptic somehow got merged, the post install script that enables TQ FTP serve and PD mapper isn't getting run. Very weird. Oh, what's this? Yeah, here's another known bug. The Bluetooth service, despite having this need dbus crashes, and the error message is that it was unable to connect to the dbus socket. But if I restart the service, if you just start it, then it will say it's already started, even though it's crashed. So if I restart the service, then it will work now. I didn't show you before, but basically, even though the Bluetooth UI would show up, you wouldn't be able to see any devices or connect to them because the actual daemon isn't running. But now that works properly. Yeah, I guess we'll what should we do? We could chroot into the rootfs and enable the services, and then pack it up again. And then ship it. And it would be fine. But I don't know. I think I'll have to take a look at this later. And in fact, I am getting hungry, so I think this is a pretty good place to stop the stream. I hope it was at least somewhat interesting, and hopefully the next one should be better. I will plan some more things. We can take a look at the OnePlus 7 again. Like, if there's anything that you'd want me to have a go at, don't hesitate to let me know, and I will add it to the list. Thanks a lot, everybody who showed up, and yeah, I hope to see you all again soon. All right.